morning everyone. I am Professor Deepa Philip from IIT Kanpur, and today we are here to at another lecture of the course titled Artificial Intelligence in Industrial Management Engineering, which is offered as part of the NPTEL MOOCs from IIT Kanpur. Along with me, Dr. Prabal Pratap Singh also co-teaches this course, and once my side of the lectures are over, then Dr. Prabal will come in and give you the hands-on experience related to this course. And we have been going through multiple topics, and this week we have been covering aspects on logic, then also we talked about a little bit about expert systems and how knowledge base and stuff like that are there. So without further delay, let's get on to today's topic. It's titled Expert Systems for Reasonable Reasoning. Right. So we already seen various components of it. So now let's say why we need to look into an expert systems. So today morning we have seen the logical reasoning and the different aspects with this. So what are the issues with logical reasoning? Okay. So I would say there are like 5 major things. So the first one is, the word that we use is brittleness. Okay. Brittleness is, the one way to think about it is one axiom or fact wrong. If one axiom or fact is wrong, system can prove anything. Okay. So this is, another way to think about it is correctness. If by chance or by storage or by some typo or something, if any one of the axioms or fact becomes wrong, the system, the conclusions might not be relevant. Second aspect is efficiency. Okay. So the way we talk about efficiency in part of this is, it has large proof spaces. So what happens here is, when you have large number of facts that comes in, so one other way to think about it is, as facts, knowledge increases, okay, proof space also increases. Okay, that is the other part, the second aspect of it. Third one is, now we will talk about is representation. Okay. One of the classic example of this is probably is not representable. So remember, it is like we said that Tom is a cat, okay, or which is true or false, but it's probably a cat. There is no way to represent that. Then the fourth one is, there is no notion of combining evidence. So individual statements still form the crux of the problem. There is no mechanism available to combining the evidence. Then the other one is, it doesn't provide confidence in the conclusion. Confidence in the conclusion. The logic is that people always have an issue with the machine, but then again the fact that you will keep on arguing that whether you actually have the entire facts available with you, so that the conclusion that is derived from the facts or the knowledge is actually, that won't instill enough confidence in you in that regard. Okay. So continuing, so what's an expert system? Okay. Or the question it is like, what is the logic behind it? And the main aspect is an attempt, it is an attempt to model the expert decision making, the expert's decision making, or the decision making process of the expert in a limited domain. Okay. So that is the logic part of it. So it's an attempt to model how the expert is making a decision. Couple of examples as part of it, right? Which are some of the domains. One is medical diagnosis, that is where the largest numbers happened. The another one is computer configuration or computer configurations. The other can also give you a different thought process. Then machine fault diagnosis, etc. Fault diagnosis, etc. As few examples. The key requirement. Key requirement. What do you need mainly? Okay, key requirement. Needs a willing expert. So you need an expert who is willing, okay, willing to work with you. Now, then other one is second one. What is the other requirement? Okay, it is requires knowledge representable as rules. Okay, you need knowledge that can be represented as rules. Okay, example, won't work for chess. Okay, then the other one is also the preponderance of evidence for decision, not proof. Okay. So you need evidence for decision, preponderance of evidence for decision, not for the proof. Okay. So this is the aspects of expert system, the basic aspects of it. So continuing more on it, so what is it at the end of the day? Okay. The simplest way to say it is a computer program. So expert system is a computer program. And what does it contain? Okay. So contains expert knowledge about a particular problem. Okay. Contains expert knowledge about a particular problem. How is it created? How is it developed? Often in the form of a set of if then rules. Okay. So the three questions: what is it? It's a computer program. What does it contain? Contains experts' knowledge about a particular problem. And how is it developed? Contains a set of if then rules. What is it capable of? Okay. What is the expert system capable of? Able to solve problems at a level equivalent to or greater than human experts. So the logic is that what is it capable of? It should be able to solve problems at a level, okay, a level equivalent to or greater than human experts. We should be able to solve it at the same level as that of the human expert or greater than, better than the human experts. Okay. So major activities associated with expert systems. What are the major activities associated with expert system? Okay. So, you have one is knowledge acquisition, second one is knowledge representation, third one is knowledge interfacing, fourth one is knowledge transfer to the user. Okay. So, these are the the four major activities. You want to acquire knowledge, then you want to represent that knowledge, then you have to interface the knowledge and then transfer it to the user. Now, we talked about that we is trying to mimic or capture what a human expert is trying to do as part of this. Okay. So, what are the characteristics? What do we quantify or what do we call as a human expert, or characteristics, capabilities of a human expert? Okay. So, able to recognize and formulate the problem. So, the first thing is they should be able to recognize and formulate the problem, part 1. Okay. Part 2 is they should be able to solve problems quickly and properly. Okay. That is the second thing. Third one is, and a human expert should be able to explain the solution. How did the solution come through? Okay. Fourth, the human expert should be able to learn from the experience. The fifth one is they should also be able to restructure knowledge. Okay. They should be able to create new patterns and restructure the knowledge within their mind. Then they should be also able to break rules. Okay. Sometimes specifically required for innovation, need to break rules for this part. Then determine relevance, whether this is relevant or not relevant. So, the main characteristics, as we said, they should be able to recognize and formulate the problem, okay. Identify there is a problem and then formulate it, solve problems quickly and properly. Quickly, this is timely and correctness, and then they should be able to explain the solution, the why should be provided. They learn from the experience, okay. When more and more problems that they solve this particular fashion, they should be able to do accordingly. Restructure the knowledge, whatever they are acquiring as time progresses, new facts comes in, they should be able to restructure the knowledge, break the rules. Obviously, yes, if you want to do what you call as innovation or disruptive innovation, then you need to break the rules and then determine the relevance. So, those are the characteristics of human experts. So, then the next question is, if so, the humans are so good, then why do you need an expert system? What is the motivation behind having an expert system? The first main reason, the major reason is reproduce expertise. Okay, that is the first thing, reproduce expertise. Okay. That another way to think about it is make available. Okay. You have to make the experts available to them. Okay. Second one is capture expertise for future. Capture the expertise for future. Okay. Why do you need to capture the expertise for future? Simply because experts die. I am talking about human experts. Okay, human experts die. We all have a fixed lifespan. Then third one is combine the expertise of many. Instead of one expert, we can combine the expertise of many. Okay, didn't work yet. Okay, we said we can do this, but have not worked yet. Now the fourth one is teach expertise. The other logic was, okay, other motivation behind the expert system was teach expertise. That also didn't work yet. That also has not happened. Then the fifth one is expand the application areas of computers. Application areas of computers. Okay. Let new frontiers where computer can be used and get things done. Okay. So these were the other logic behind it. Now let's talk about the architecture of the expert system, okay, or expert system. So we had already talked a little bit about this, but now let us talk a little bit more in detail. Okay. So we talked about something called domain knowledge. Okay, domain knowledge, and we said it is as if then rules. So the domain knowledge is stored as if then rules. Okay. Then the second part is what we call as inference engine. Okay. That is two options are there. We talked about this earlier briefly, backward chaining. So a small example of this, and other option is forward chaining. We have not seen that yet, but we will go through a small example. Forward chaining. Then third one is calculus for combining evidence. For combining evidence. Okay. So the logic here is construct all proofs, not just one. And we saw in the other example where black key holds, whether it's valuable, we have seen it's not just stopping when you found the solution, but also constructing the all aspects of it, right. Then the last part is explanation facility. Explanation facility. Why do you need an explanation facility? The thing is, can answer why. Okay. The why is the critical question, and it should be able to answer why. Now, there are many categories of expert systems, okay, multiple categories of expert systems. Now, we are going to look into some of those categories of expert systems. So, the first one is what we call as prediction. That is the common type of expert system. Okay. So, what does it do? Inferring likely consequences of given situations. Okay, inferring likely consequences of given situations. Then second part is diagnosis. Okay. So what is that? Is inferring system malfunctions. From observations. So here the prediction, you are looking at the consequences, okay, of given situations. In here you are predicting or inferring malfunctions from observations. So this is a type of interpretation. It's kind of interpreting. Okay. Then third one is design. So, what are we doing in design? Configuring objects under constraints. Okay. So, you have limitations or constraints and you are configuring them under constraints. Constraints, you can think about constraints as limitations also. Another one is planning. And what do planning do? It is developing plans to achieve goals. You have various goals that you need to achieve and you need to develop plans to achieve those goals. So, that is the planning. Then you have monitoring. Okay. And what do you do in this? Comparing observations to plans, flagging expectations or deviations. So, the planning and monitoring sometimes goes hand in hand. So, while planning focuses on achieving goals, the monitoring basically compares the plans, observations to plans and identifying expectations and deviations, right. Then you have control. Okay. This is another planning, monitoring and control. It is interpreting, it is very common in systems engineering, interpreting, predicting, repairing and monitoring system behavior. So, in a control you are looking at interpreting, predicting, repairing and monitoring the system behavior. Okay. And obviously, what is repairing? Okay. Repair is it's administering a remedy, that is repair. Okay. So, these are the categories of the expert system. So, we have gone through 1, 2, 3, 4, 5, 6, the most popular categories of expert systems. Now, how do we, if you are to design one, then how would we design an expert system? So, the components of the expert system. So, I would give, let us say, let us assume this as your expert system. Okay. Okay. Expert system, and then in this I am going to create, first one is user interface. Okay. Then the second one I am going to do is inference engine, and the third one I am going to do is knowledge base. So, how are they connected? User interface deals with the interface engine deals with the knowledge base, and this is back and forth both sides. Okay. And so, that is why double sided arrow. Now, let us talk about user interface first. So, okay. So, a facility for the user to interact with the expert system. With the expert system. Okay. It is a facility for the user to interact with the expert system. That is the first part. Now, let us take the second one. Okay. Inference engine. reasoning, or you can think about as thinking. Okay. Makes logical deductions based on knowledge in the KB, knowledge base. Okay. That is the inference engine. Now, the last part is the knowledge base. Contains the domain knowledge. Okay. So, that is the third aspect. Now, you should also understand that I would also like to put an arrow here for the inference engine, and also another arrow here for the knowledge base. Okay. So, both are basically external interface for updation. Okay. So, it is interfacing with the environment or the external system to interface, and what we call as get the information, or the inference engine captures new additional ways of inferring things, and knowledge base captures new knowledge. Okay. So, I am going to say here in this regard is just to write here, it contains domain knowledge necessary for understanding, formulating and solving problems. Okay. So, this is a side note as part of it. It contains the domain knowledge necessary for understanding, formulating and solving problem, and if it is not sufficient, then you take it from the outside and do it forward. So, with this architecture diagram, we will come to a quick stop right here, and then we will continue with the rest of the contents in the next class. Thank you very much.